Right, it's nearly lunchtime. It's going to be a nice, fast-paced, high-level look at large-scale log analysis and how we implement it within our team at work. So get ready to go through that. Happy to take questions at the end and over lunch if anybody wants to come and find me. So some of you guys know 7Elements, local security consultancy. Primarily, we deal with two main core aspects of our business. One is security testing, often referred to as penetration testing, actually hacking into networks, applications, mobile platforms, organisations, hacking humans through social engineering and all that good fun stuff. And then the other angle is incident response, when it has gone wrong within an organisation, and we get asked to come in and bring our expertise in to try and understand what's happened, size the issue, and then proportionally respond and help the organisation recover. I think we're very well positioned in that space because of that attack-led knowledge that we derive from actually hacking systems on a day-to-day basis. We are often gaming and thinking the same way as malicious agents would be, and therefore we're able to translate that approach into the problem solving that's required as part of an incident. And that's where we sort of blend those two areas. Now, today's talk, as I said, quite high level and quite quick to go through, but we're going to bring Leo Tolstoy and War and Peace, Donald Rumsfeld, 2001: A Space Odyssey, a bit of Star Wars, and the Eiffel Tower, all to play in describing big data and how we're dealing with it. So hopefully you'll see that play out across the slides. So clearly, Jamie's already covered this for me, so fantastic, and thank you very much for that slide being pretty much an exact copy. For us, there is a definition required so we understand what we're talking about, and knowing that we're at least sixth on the list of talks today, I did feel it was a bit of an obligatory definition. But again, I reiterate what Jamie said, it's about data sets that are so large or complex that actually traditional methods just don't cut it anymore, and this is where we've certainly had to change our approach to deal with what we're referring to here as big data. But for us, it's primarily large volumes of structured data, which do cause a challenge in their own right. So I really wanted to sort of pull out what do we mean by large data. So we'll pull that theme through a number of different slides, and there's a couple of incidents that we've dealt with that have required managing large data sets, and we'll pull on those and give some insights. But for me, the Donald Rumsfeld part of this talk, the known knowns, known unknowns, and unknown unknowns. For us, if it's a known known, then we're dealing with things that should have been caught by IDS, IPS, web application firewalls, other antivirus, intrusion detection and endpoint protection, because there should be a signature, there should be available defences against that, and you really should have been mitigating it before it actually happened as an event, or you're looking at the output of a firewall log or an IDS log to see the matched alert of something that's actually happened, it's triggered against this known issue, and we can go and deal with it. What we're primarily dealing with is what I would refer to as known unknowns. An event has happened within an organisation, within an enterprise. There are some traits as to what has occurred, and then we are having to use our problem solving and our skill sets to actually work out what has occurred, what is the issue, and therefore what does this mean to the organisation and how do we remediate it. So it requires a lot more problem solving, a lot more research and analysis of the data, because there isn't a known signature to go and match against and alert against. So that's where we're sort of challenged. So we talk about size. And size does matter in this context. So we've heard a lot of numbers being bandied around this morning about event volumes, size of data, petabytes, and so forth. For us, to put a bit of structure into this, we're going to talk about an incident where we actually had an enterprise environment. It had multiple load balancers sitting in front of 8 application servers that then obviously sat in front of a whole stack of databases that served the content to those application servers. There had been a compromise in that environment, and one that didn't match a known signature. They saw some odd behaviour within the applications that we got brought in to do the analysis. And we needed to build up the picture. And actually the event could have taken part over the last 3 months. So actually we had to consume quite a large amount of Apache log files in this space. And we were given an initial cut of data that was 3 terabytes worth of size. Now, actually, that doesn't sound too big. If you imagine you can go to Argos and for £70, you can buy an external 3 terabyte hard drive now. So, it's standard data sizes that we're getting. It's consumable size of data. But when you actually think about it, how big is that when we're talking about Apache logs? So I started doing some sums on this. And we actually found that if you take 3 terabytes worth of log file and you actually look at the total lines of code, lines of log there, we're talking about 26 billion lines of Apache log file. That's quite a large amount of data, but still that number didn't really mean too much. So then I looked at how many words that would equate to within that file set, and that was 329 billion words equivalency inside that data set. Again, nice big scary number, but what does that actually mean? Well, that actually means that we could fit that amount of words into 577,000 copies of War and Peace. So that's the Leo Tolstoy's link to this talk. And again, that seemed to be an awfully large amount of books, and I couldn't really quite get my head around what did that mean. So then I worked out, well, if we stack each of those books on top of each other, how high would that actually be? And the answer is, it would be 117 Eiffel Towers stacked on top of each other in height. So 3 terabytes worth of log files is actually a massive amount of data when you think about it in that context. So, and even in that environment, 8 servers, 3 months worth of data, and we've got a phenomenally large data set to start working with. So we had to manage that. Also, we have to manage the fact that those logs are split across the 8 servers, and those logs are then further split by log rotation. So we've suddenly got an awful lot of data to actually manipulate, manage, index, and actually deal with. So how did we start looking at that? Well, clearly, Star Wars reference, we needed a bit of Jedi trickery here. We needed to blend technology and our own skills in this space. We were not going to be able to just use Notepad, Excel, standard log parsing, because it just wasn't going to be up for the task. So what we've done actually internally in the team is we've built our own tool that helps us with large-scale log analysis. It's built on an extensible Python controller using RESTful JSON-based APIs, and it pulls on open source technology that sits out there already. There's no point in reinventing the wheel if you don't have to. So we use Logstash, Elasticsearch and Kibana as the underlying technology. And as I said, we've built our own API that sits on top of that, which makes it usable for us in what we're trying to achieve. Now, putting this into context, a lot of the incidents that we're managing are, by their nature, unplanned. We don't know we're going into those environments. We get called up as a matter of urgency, and can we react and get people on the ground rapidly. So we're not dealing with integrated SIEM platforms. We're not dealing with environments where they're taking all these logs and they're doing log analysis on a daily basis. We just get access to the servers and told to get on with the task. So we have a suite of tools that we can bring with us that allow us to do this job. Now, the key driver when we're actually managing some of this data is that we need to be in control. Do not let the tool tell us what the answer is. If you get into that mindset, we'll see later on, things can get a little bit tricky for you. So what we're looking at here is raw access to the logs, doing some manipulation and some data carving out that actually allows us to do our job, but allowing the responsive engineer that's actually engaged in this event to use their problem-solving skills to actually go back to the data themselves and actually interrogate it and work out the answer. Because I said, we're dealing with known unknowns, so we're actually looking for things in the data that don't currently match a signature. But there's clearly some things there that we can make our life easier with. So, what do we look like? So, bearing in mind this is an internal tool, this is not a product that's for sale. It is purely for our engineers to make good use of resource. We talked about using Kibana as a graphical representation of the data. Now, if any of you are working with large-scale data, Kibana is fantastic for being able to see it visually. And there's been a lot of visualization used in big data, and it really helps. Humans are good at looking at pictures. They're not good at looking at single lines of code often. So being able to graphically visualize what's going on with the data sets can actually help you in terms of targeting areas of interest that you'd want to go into. So we always have that ability to drop back into there, combined with the ability to go and look at the raw logs at the same time. So we can look at a particular event and go and see the log. We're not extracting some data out of there that means nothing. We can actually go back and look and query it and validate it for ourselves. So, but clearly, having an API and being able to interrogate the data, we can run tools and we can run scripts as we need. We've got a whole set of signatures. So we can actually quickly analyze that data for known attacks. And that's quite important because there's going to be a lot of noise in these logs. Some of that noise may be relevant to the case we're dealing with. Others might support certain views that we may take on it. But certainly a lot of data, it's actually just noise that we want to extract out of the database. So if there's a signature that matches a particular type of attack, such as, say, directory traversal in a Windows-based system, but we're looking at a Unix-based system, actually we can discount all of that traffic because it's not going to be relevant to the environment we're sitting in. So actually if we can extract that out of the data and clean the data up for us, actually that makes a huge amount of help. But also one of the other things that we wanted to do was create evidence as we went along. There's no point in repeating activity if you're going through this, doing all your analysis, and at the end of it, you don't know how you got to the answer, and you have to go back and repiece it all together again. So let's extract the data out as we go along, create the evidence that actually helps us. So there's a number of things we do. We create a summary file that tells us, as you'd expect, a summary of the activity. The summary evidence, if we've actually got something that's matched a known trigger, we dump it in there so we've got an easily referenced table to go back to. Every IP address that has hit one of our known signatures gets put into a suspect IP list, because what I want to go and do is look at that IP traffic in its entirety and see what else that machine's done. So this is getting into the known unknowns. It might have done something we know has triggered an event. So say it was doing some reconnaissance activity earlier on, and then actually the targeted attack it did that was successful didn't match a signature, but I've actually got all of that reconnaissance traffic. I can then go through and actually piece together what else has that IP address done. Has it done something else of interest, and include that in my evidence. But equally, a timeline. So every single IP address that's done something, I've got the first time it's come in and the last time it was seen in the log. So I can build that timeline up very, very quickly as to what's going on. Because a lot of our clients, the first thing they want to know is, when did this happen? Is it still happening? You know, and so actually these types of answers really, really help rapidly. Raw logs, everything that we capture, we keep a raw copy of the section of log that it came from, because I want to be able to go back and interrogate the logs. I don't want to hide the logs from the analyst that's doing the work. We need to go back and actually verify our activity. And what we can actually do in this space, and I'll just show you one for example. So raw logs by signature. So in that subfolder, that's a Drupal pre-auth SQL injection attack signature that we've got. And you can see that it was found in the logs from 2014, 22nd of October, and the timestamp that it was actually matched at. So useful information straight to the eye without having to go into the folder that actually then contains more information about that attack. So again, we're pulling out information and making it readily usable to the user that's actually doing the research for us. But equally, when we actually find a new signature, something of interest, so we've interrogated this, we've found some interesting traffic, generally a lot of the time through manual activity, certainly through the actions we're doing, we can then create a signature. So in this instance, the post request looking for Q equals node, etc. If we found that through a manual interaction with the logs, we can then feed that back into our tool, rerun the tool against that signature, and we'll then extract everything out of that log file that relates to that. So again, new IP addresses, new timelines, new other activity that might have been going on. I'd then go back into those new IP addresses that got thrown up as being seen to interact with that parameter, and then I'm starting to manually look through those logs. So straight away, I've actually got a much more structured approach to a very large data set that actually is supported by scripts and by signatures that we can generate through a lot of our research and our attack traffic anyway, so we know they're valid attack signatures. We're not going to be matching on something that's just not going to be, well, it's always going to be a false positive, or it doesn't actually materially matter in this context. So I'm in control. If I'm using a Unix system, I'll only run Unix signatures. I'm not going to run Windows and therefore get loads of 404 responses back in the logs, because they're not going to support my investigation at this point. So how does that work in reality? So that's, again, that cyclic nature of going back through the evidence. What do I now know based on what I've learned, and what does that mean for my next course of action? And we can use that tool to go backwards and forwards as necessary. So how does that help us in our response effort? Well, this first one, so we go back to the large-scale incident we did with 3 terabytes of data. The organisation was being attacked by a number of external threat actors at any given time, all using a point-and-click graphical tool that allowed them to compromise a struts vulnerability in the enterprise. We were very quickly and rapidly able to work out where these attacks were coming from, the number and the volume, when they were still being compromised on an ongoing period. We could look back and see when the attacks actually started, so how early on in their environment had they been compromised. But it allowed us building up that picture and the knowledge of how the attack was being manifested led to a number of different things. Firstly, seeing the attack traffic and what they were targeting allowed us to go and do some very targeted research on the internet, which led to finding the toolkit that actually was being used to deliver the activity. Finding the toolkit allowed us to then start looking at the skill set of the person that was actually delivering the attacks. Because it's a point-and-click tool, actually the skill barrier that was required to go and do that had been lowered. So it wasn't necessarily a serious organised crime-led attack. It wasn't a highly targeted attack necessarily. It opened up the playing field, so it allowed us to play out a couple of different hypotheses when we're trying to work out what was going on. We also saw in the logs referrer fields being used to point to where the attack was actually being directed, specific vulnerable parameters within the applications. All those referrer fields were coming through a particular Google search. So now we knew people were actually targeting the technology that was flawed, not the organisation themselves, for the organisation being the organisation. And when we repeated those results on Google, unluckily the company in question was the 4th on the first page of that return. So literally they were just copying and pasting the URLs out of Google into their tool and clicking go, which then starts making me think actually the skill level's going down again. These people are just opportunistic rather than being highly targeted. And we could see the volumes of attacks, and we could see the payloads that were then getting delivered, because the struts exploit allows you to arbitrarily write code on the remote server. So the next stage, when you knew that could happen, was to then upload your own shell scripts to the servers to maintain access. In the logs, we could see all of those files being named, created, and then called. So we knew all of the malicious backdoor code that was being deployed onto those servers, which meant we could create a list of files for the organisation to go and search on other machines within their infrastructure to see whether or not those machines had those compromised files on. And we actually found other machines that weren't at first point internet facing, but had been onward compromised within that environment through that process. But the most important one for this one, we saw a huge volume of attacks. At one point there was 70 unique IP addresses, each targeting that infrastructure, each uploading their own malicious backdoor code, overwriting other people's code, taking over other people's shell scripts. It was quite like a bloodbath going on at one point. Internally, somebody interpreted 70 addresses attacking their servers at any one point was a sustained and coordinated attack, and rang the alarm bell that something really, really, really bad was going on, and the next step was that their entire organisation was going to be wholeheartedly compromised, and really panicked a lot of the senior execs. We were able to go back to the data that we'd collected and broken out and actually work out that in all likelihood they were completely disparate people all just hacking that URL because it was on Google. It wasn't a coordinated attack, and therefore we were able to temper the panic that was going on internally and take a much more proportionate response to the incident. So I think it put a lot of context around what was going on and allowed the organisation not to knee-jerk unnecessarily, which I think was very powerful, because that way madness lies and a lot more money would get spent on an incident than necessarily required. So that's how that tool looks in terms of the output we get. But another one that we actually found, and this is quite good fun, we got tasked by another company that believed they'd been compromised. They wanted to know when, because they need to know how far back to roll back that server, because they didn't want, the advice that they'd been given was to roll back for well over a month. They couldn't afford to do that, because to go back over a month would lose a significant amount of development work they've been doing, cost them a lot of money to repeat that effort. So they brought us in to look at the logs to see if we could actually pinpoint the exact day and time that those guys had been compromised, so they knew where to roll back to and move forward from there. So they gave us 1 million lines of Apache log. And we did two things. Again, it was a known unknown. We knew that they'd been compromised, but at that point there was not a signature that went with that event, so we couldn't just match it against a known signature set, so we had to do some research. And we had a combined activity. We had a couple of guys focused on recreating the exploit in our lab environment. Once they could get a working exploit with the available proof of concept code that we'd found through our research, we then looked at the logs, analysed the logs to see how it left information on that environment and how it actually manifested itself in the logs. And then we could feed that into our tool. But equally at the same time, we were manually going through the logs to identify it from first principles as well. And I would estimate we probably spent 4-5 combined man days to find the answer, which was these 9 events out of 1 million lines, 9 unique events within the logs that actually showed that they had been compromised and the dates that they'd actually been compromised. Once we'd had the signature, we then ran the signature through our tool. The tool took 2.5 seconds to give us the same response. So clearly, taking a programmatically based approach and a structured approach against querying large data sets with a scalable tool works as long as you've got the signatures to go looking for. We can't lose sight of the fact that we need the signatures in the first place. So that's where Space Odyssey 2001 HAL comes into this. So basically, we need to be careful when we come to big data and large-scale analytics and putting all of our trust in a tool giving us the answer. We need to be in control of that. We need to be driving it. We need to be using our critical thinking. We need to be asking the so what questions. You know, what does it mean to me? What does it mean to the environment? Is it an issue? And what does it mean to my investigation? We need to be driving all of those activities. If we leave ourselves at the mercy of a tool giving us the answers, then actually we will be lessoned for it, and we won't necessarily get to the point that we need. So I would urge that as part of our approach to big data and big data within security is we need to make sure that we're training our engineers, our security professionals in the art of data interrogation, data analytics from first principles, from the ground up, give them the skills to be doing this manually, and then give them the tools that support that activity and make sense of very large scale and large data sets and complex data sets, not the other way. We do not need to be teaching them how to run a tool. If we do that, I think we're going down a very dark avenue that's not going to do us much good in the next couple of years. And that is literally my pre-lunch quick canter through how we've been approaching data analytics.
So, questions? Do we have any questions? Yeah.
The signatures that you identified while you were doing the analysis, I mean, that sounds like kind of crucial thing to know, like the crucial thing to know so you can run the tool. Is that something that you share with other firms, or is that kind of your secret?
Is that our secret sauce? So it's an interesting question. We don't commercialise the output. In fact, if we can publish it back out to the community, we genuinely do. It's on our blog. We talk about a lot of stuff that we're up to and things that we find out. So we're very open in sharing in that space. Do we share our entire signature set? Currently, no. There's not an easy mechanism to do that. But we're not shy in telling people stuff that we find, and if it's of use to other people. We also use CISP, the Cert Information Sharing Platform for Cert UK, and we regularly, as we can, feed into the strands of conversation that are going on in there. So literally on Friday, I posted an update to some of the DDoS Bitcoin demands that are being made to different industry sectors with some information and some intelligence that we picked up. So we will feed back into the relevant areas.
Yes, question.
Hey David, thank you. Two questions, if I may. The first one, it might be rhetorical, but is your investigations required because these customers don't have adequate technology controls? And the second one would be, I hope you don't mind me asking, but the type of investigations you have to do you have to manage expectations so you can be prepared to undertake the work?
So first question, it differs. So in the event of the struts vulnerability, unfortunately for that client, that technology had a number of flaws over a period of time. And on the post-incident response mop-up, they discovered they hadn't been, they knew they hadn't been patching that environment because it was a difficult environment to patch, and therefore they put it on their risk register as a risk that they would carry because it was never going to happen because they had a web application firewall protecting them. So it was technology failure on that front, but they knew they weren't patching. On the event of the Drupal pre-auth SQL injection vulnerability, it was a disclosed vulnerability that suddenly came out of the blue. Everyone was patching, but they then came out with oh, by the way, and Drupal telling everybody, you've probably been compromised from a month ago. Sorry, you need to just roll back. So they were sort of pushed into a corner on that one, even though they had a robust patching process. I'm not too sure I get the last part of your question.
Sorry, yeah. As you describe effectively developing a tool, so my question's around, do you sometimes find or regularly find that to do the work you do, you have to very rapidly develop the capability, and if you do, you have to manage the expectation of the customer to be able to do so?
So we sort of educate customers in terms of expectation of time and effort that it will take to do particular activities and the cost involved in that. We do not back that sort of cost on to clients. That's part of our internal research and development that we do. If I put it into a slightly different context, we've just done a recent engagement where we needed to exfiltrate data out of an organisation, and because of the particular nuances of that environment, it was going to be very difficult to get the data out. So we actually wrote a DNS-based data exfiltration tool in a couple of days, because it made our life easier and it allowed us to accomplish our aim. That's not a cost or a expectation to the client, it's just what we do to actually go and deliver our service.
I'm just thinking to respond scenario where they might expect you to do something in a certain amount of time. And
yeah, well, it's just you just have a sensible adult conversation with them, and if you can explain how large a data set that actually is and the mandates that will take to go through, then actually that's it's an easy conversation to have. But clearly that one paid a huge amount of dividends to them, because without that data and that knowledge, I do thoroughly believe they would have knee-jerked at the internal person shouting that they were under a sustained coordinated attack, and that would have completely changed the picture. They may have actually turned off their entire internet presence in that environment to protect the rest of the organisation, which would have had huge catastrophic implications, revenue and PR-wise for them. We were able to manage their expectations in that space, keep that service up and running, because we actually showed that there was no further compromise from that zone. These guys didn't actually know what they had actually gained a foothold on. Actually, that environment had PCI data in it, had credit card data. None of the attackers actually went and targeted the systems that held that data. They were just happy that they'd compromised a machine. So we knew that we were dealing with quite low-skilled attackers at that point that literally were governed by the tool that they were using rather than systematically going through the environment that they'd actually gained access to. And so that's a bit of upfront cost saved a huge other out cost somewhere else.
Thank you.
Do we have a final question? No
Good.
final question? Okay. Please do give David a